So students, in last video we discussed about Ohm's law. In this video we will cover the topic resistance. So as you can see here, that the term resistance was firstly introduced by George Simon Ohm in 1857. And according to the Ohm's law, we all know that voltage difference or potential difference across the terminals of any conductor is always proportional to the current flowing through it. Okay, so it is called Ohm's law. And whenever we replace this sign with equality, we will get V is equals to IR, and R is a constant of proportionality, you can say. And whenever you separate this R, you get V over I. What is resistance actually? So it is property of a conductor to resist the flow of charge, or you can say to resist the current, because flow of charge is called current. So let's talk about its SI unit. So you can see here, SI unit of resistance is ohms, and it is also called volt per ampere. Now, what is the definition of 1 ohm, or you can say unity resistance? The definition: if potential difference across the two ends of a conductor is 1 volt and current through it is 1 ampere. So here we have two conditions, that if we have a conductor A and B, these are the two terminals of this conductor, and according to the definition, potential difference across the terminals must be 1 volt. So from here to here, the difference of the voltage must be 1 volt. And another condition is that current should be 1 ampere. If these two conditions are followed by this conductor, then definitely you can say that this conductor has resistance 1 ohm. So you can see here the formula: 1 ohm is equals to 1 volt over 1 ampere. So next topic is factors affecting the resistance of any conductor. Resistance of any conductor depends upon length of the conductor wire and cross-sectional area of that wire. So here we have two factors which are very important: length and cross-sectional area. Third is temperature. To know that ratio of V and I is always a constant, that is called resistance, but this expression is valid only at a particular temperature. So temperature is another factor on which resistance of any conductor. First two things, length and cross-sectional area. One more thing here, what do you understand by cross-sectional area? So for example, we have a cap. In this cap, what is cross-sectional area? Cross-sectional area is this portion. This portion is called cross-sectional area. So resistance of any conductor wire depends upon the length but proportionally, and resistance of any conductor wire depends upon the cross-sectional area but anti-proportionally. Yet R is proportional to L and R is anti-proportional to A. Then whenever you will combine these two equations, equation 1 and equation 2, we will get R is equal to rho. This sign is called rho L over A. Rho, what is rho? Rho is resistivity of the conductor's material. So here we have SI unit of resistivity. Resistivity is always measured in ohm meter, because if you will separate rho from this equation, you will get rho is equals to RA over L. And if you will put the SI units of these three physical quantities, then R have ohm, and cross-sectional area has meter square, and length has meter. So meter to meter square is cancelled, and the last result is ohm meter. So resistivity will have the SI unit ohm meter. So here we have SI unit of the resistivity is ohm meter. Characteristic property of material. For metals and alloys, if you see, then these two substances are low resistivity materials. Their resistivity lie in the range 10 to the power minus 8 to 10 to the power minus 6 ohm meter. And if you are talking about rubber and glasses, so these are highly resistive material, and they will have resistivity in the range 10 to the power 12 to 10 to the power 17 ohm meter. Okay, so if you will express the resistivity in terms of resistance, then what should be the proper definition of resistivity? Here we have, since we know that R is equals to rho L over A. So from this expression, if we'll put the L is equals to 1 meter and A is equals to 1 meter square, or you can say that length is unity and cross-sectional area is also unity, then R is equals to rho. So actually resistance and resistivity are equivalent to each other. So here we have another definition or another expression for resistivity, that is, resistivity is resistance offered by 1 meter long wire having cross-sectional area 1 meter square. So if we have a conductor wire of unity length and unity cross-sectional area, then definitely its resistance is called resistivity. One more thing, that resistance and resistivity both vary with the temperature. It's a very important thing and should be noted that resistance and resistivity both vary with the temperature. If you change the temperature, both will vary. So on your screen there is an example. Here in this question, length of the conductor wire is given 1 meter and resistance is 26 ohm. Diameter of the cross-sectional area is 0.3 meter and resistivity is asked here. And you can see that resistivity is asked at the same temperature on which resistance is given, that is 20 degrees Celsius. So temperature is not changing here. So it's very simple question and we can easily solve it. So we have R is equals to rho L over A, and the required things are given, that length is 1 meter, it is in SI unit or MKS unit, and R is ohm, that is 26 ohms, so it is also in SI unit. But here is a problem, that diameter is given into 0.3 millimeter. 0.3 millimeter. So you have to change this diameter into meters because meter is an SI unit of length. So if you'll change this, so from millimeter to meter if you'll move, then you will get 0.3 into 10 to the power minus 3. So if you will separate the value of rho here, you will get rho is equals to RA over L. So let's put the value of R. R is 26, L is 1 meter. So cross-sectional area is always circular in nature. So you will put the value of pi R square. Pi R square. So R is always D by 2. Place the value pi R square means D by 2 square. So 26 into 3.14 into 0.3 into 10 to the power minus 3 into 0.3 into 10 to the power minus 3 upon 4. So if you solve whole the expression, you will get almost 1.84 into 10 to the power minus 6 ohm meter. So this is the resistivity. This is the resistivity of the given conductor material. So if you will compare this resistivity with the resistivity table, you will find material of the conductor wire is manganese. So this is all about the resistivity. In next video, we will do some other numericals and we will cover some very important topics of this chapter, electricity. You all are requested to prepare notes of these topics in your own way.